Okay class, let's continue with the next example for non-homogeneous system. So we have here x plus 3y plus z equals to 3, 2x plus 8y plus 5z equals to 10, x plus 7y plus 7z equals to 11, 3x plus 11y plus 7z equals to 15. Alright. Okay, firstly write in the form of augmented metric 1, 3, 1 slash 3, and then we have 2, 8, 5, 10, and then 1, 7, 7, 11, 3, 11, 7, 15. Okay, next step. Okay class, now let's check out your row echelon form. So we have here, it is in the form of ladder here. So it's as you can see here, okay, your last row is the 0 row. So make sure if you have a 0 row, it should be in the last row. Okay, alright. Okay, next steps, identify the leading variable. Okay, so the leading variable here is x, y and z. Okay, it is x, y, z. Okay, since you have the leading one is in each column. Okay, alright, then continue. Next step, you will have your back substitution. Okay, next, continue with back substitution. Okay, we have z is 2 for row 3, and then row 2 we have y plus 3 over 2 z is 2. So y is 2 minus 3 over 2 z. Y is 2 minus 3 over 2 times 2 equals to negative 1. And for row 1, you have x plus 3y plus z equals to 3. So x will be 3 minus 3y minus z. And substitute, you will get 3 minus 3 times negative 1 minus 2, which is equals to 3 plus 3 is 6 minus 2 is 4. Okay, so the answer x, y, z equals to 4, negative 1 and 2. Then we can conclude that this system is consistent and has a unique solution. Unique solution means you have the value for each variable. That is, here we have x is 4, y is negative 1 and z is 2. Okay, so let's continue with the next example C. Okay, so now your first augmented metric will be 1, negative 1, 1, 1, 1, 2, negative 2, negative 3, negative 3, 17, negative 1, 1, 2, 2, negative 10. Okay, so let's start with your ERO. Okay class, so this is your REF. Okay, so to solve this system, next step is you need to identify the leading variable and free variables. Okay, so look at here, we have the leading variables is your x and z. Okay, why? Okay, look at here, each column represent x, y, z and w. Okay, so the only column that has the leading one is x and z. So meaning here, the leading variables is your x and z. Okay, while the other variables, it will be as your free variables. Okay, so the free variables will be y and w. Okay, once when you have the free variables is y and w, okay, what you have to do is you have to you have to assume your free variables as other value. For example, let y is t, for example, where your t is any real number, and let your w is, let's say, s, where s is also any real number. So this is what we call as the arbitrary value. Okay, arbitrary value. Okay, so we will assume that the free variables as any variables in the form of t and s. Okay, and with the same steps is now you have to use the back substitution. So now your back substitution will be, okay, so starting with the last row, since your last row is a 0 row, then you will continue with the second row. So your second row R2 will be z plus w, right, equals to -3. And your leading one is z. Make your z as the subject. Will be z is -3 minus w. Then, so look at here, we have w here. That means you will substitute your w as s. Alright, so now we will have it is -3 minus s. Okay, continue with row 1. So your row 1 will be x minus y plus z plus w is 1. Then when you substitute, make your x as a subject, it will be 1 plus y minus z minus w, and you will get, so substitute the value that you have here. So we have y, z and w. So we have here y, w and also your z. Okay, then when you substitute, you will get it is 1 plus t minus -3 minus s minus s. Okay, simplify, you will get 1 plus t plus 3 plus s minus s, which is equals to 4 plus t. Okay, now your answer here will be, so we will write in the form of matrix. So we have here x, y, z and w, right? So x, y, z and w. It will be, what is your x? Your x is 4 plus t. Your y is t. Your z is -3 minus s. And lastly, your w is s. Right. Okay, so here we have a two arbitrary value. Okay, if you write in the forms of linear combination, it will be, firstly, you will write the coefficient of number. So the number that we have here is 4, -3, right? So we will have here, so here we have 4 and -3. Okay, and the rest will be 0 and 0. Plus, okay, now for t, okay, let's see the coefficient for t. So the coefficient for t, we have here 1, 1. Okay, so now it will be 1, 1, 0, 0. And another one we have for s. It will be 0, 0, -1 and 1. So this is your linear combination. Okay, we call it as the linear combination. Alright, so we can conclude for the system. The system is consistent and it has infinitely many solutions. Okay class, let's continue with example D. So we have an augmented matrix 1, -2, 4, 2, 2, -3, 5, 3, and 3, -4, 6, 7. Okay, let's continue with the ARO. Okay, now let's try to solve this matrix. So if you can see here, your last row, it is 0, 0, 0 and a number. Okay, in this type of question, so we see that the system is inconsistent. Okay, we say that the system is inconsistent and has no solution. Why? Alright, so look at here. Okay, we have here this one. Okay, so if you write in the form of equation, it will be 0x plus 0y plus 0z equals to 3, which is impossible. So 0 things cannot be equal to 3. So that's why we see that this system is inconsistent and has no solution. So if you get in the form of this matrix, okay, augmented matrix, after you have reduced until REF, then we just conclude that the system is inconsistent and has no solution. So you don't have to find your x, y, z, and you don't have to use the back substitution.